Hello, hello. How are you doing today? This is awesome day for a conference. Hopefully we will get it nice, and we are here to get about information about Vertex AI pipelines for your machine learning ops. Hello. So let's see what we have today here for the audience who joins this track. My name is Márton Kodok, and I'm a GDE on cloud since 2016. And my favorite products are BigQuery, Cloudrun, Cloud Functions, and now Vertex AI as well. I'm a Romanian, but born Hungarian, so I speak 3 languages. You have met my username Pentium 10 on Stack Overflow because I answer a lot of the questions. I built out a huge reputation. The slides for the presentation will be on SlideShare. You can check it out later. You can grab the links from the slides as well. Now, my articles are on Medium. You can access it. There is no paywall, so it contains additional help information for you in order to run your pipelines. Let's discuss about our agenda today. We have shortly reading what is MLOps. Then we will see what is Vertex AI, how to build, train, and deploy machine learning solutions, and pipelines for your entire machine learning workflow. These are amazing things to orchestrate all the elements of your machine learning steps. And finally, we'll close with adapting to changes of data. Your pipelines need to start based on some changes of data or some state of it. We will see what that means. Join this session because at the end there will be a Q&A and a quiz. So I will have a question and a lucky answerer will get some swags, some little present from the organizers. Good. Let's see what is part 1 and to see how this is actually going to work out. So essentially, what is MLOps? MLOps could be the DevOps principles applied to machine learning systems, like development and operations, running the servers, running the stack, running the steps, as a developer and without a sysadmin dedicated to this project. Elements of a machine learning system may have, for example, a data collection, may have a model analysis, but also monitoring. All these need servicing infrastructure, all these need automation, configuration, and together they make the machine learning code in order to be useful. MLOps, in another definition, could be a continuous delivery and automation pipeline for machine learning system. We will focus on this. We will focus to seeing how we automate pipelines to build all the steps of the machine learning ops. So, if we need to discuss a bit level of automation, then there is the first level, a manual process. Then there is the pipeline automation, and level 2 is CICD pipeline automation, when you build out the code and the pipeline will get generated. If I want to expand on this, MLOps level 0 manual process, it means that you are building and processing all the machine learning models by manual actions. You start it, you build, and you deploy it manual. There are infrequent release iteration, no CI/CD. This connection between machine learning and operation system, you have manual steps. By introducing pipeline into the automation, you get a continuous training of the model. You automate the pipeline, and you achieve continuous delivery of your model prediction service. It means that the pipeline, mostly based on new data, will kick in and it will build for you a model. It builds a model that will be deployed frequently. You could release a model like a change to a website. You could release it 2 times a day. You could release it once in a week, every day, as often as your organization wants to. CI/CD pipeline automation is level 2. Here you actually try out iteratively new machine learning algorithms, new modeling, where the experiment steps are orchestrated. You need an orchestrator in order to build all the elements of it. The output of this stage is the source code and the source code of the pipeline steps. So essentially you are not building the model, you are building the pipeline steps, a JSON file, perhaps. That's pushed to a source repository. The source repository is the one that signals the events on a data change. It could be a Git commit, and based on GitHub actions, you can build out the source, run the test, and if the test succeeded, you can have the output as a pipeline. And this is the pipeline definition only. Then it kicks in the level 1 automation when you operate the pipeline. If we want to get a chart of it, we are going to see that here you have the manual process, the train model, the prediction service, and then later if you introduced automatic pipeline, you could have the pipeline triggered by new data. The new data triggers the continuous training process, like new data arrived, continuous training. The train model is being continuously delivered. It means that it is being pushed to a endpoint where you can consume it. It's deployed like a website change. Now, this is the first part, but then you can have packages and you can have source code. So essentially, if you run a development and if you run an experiment where you release code, and by releasing code, it means that you are changing the code and you are pushing the code to a GitHub repository, you can have a new source code, like a new parameter, a new feature, or why not a new file, a new data set available for your MLOps operation. Then the pipeline, the continuous integration, the CICD part, it will kick in. It will get the source code from the GitHub. It will build the packages. It will build the container. And once the container is built, automatically starting the pipeline. If we need to separate, we have here the manual process. We have the level 1 where you have the pipeline, automatical. And here you have the CI/CD on the source change and on the packages and the container as well. Part 2. What is VertexAI? VertexAI is a managed platform for practitioners to accelerate experiments and deploy AI models. So by practitioner, it could be a person who wants to do machine learning job, but there is no coding experience. There are solutions in VertexAI that needs very few code lines or no code solutions. Then you have an expertise in the data science world where you need to run the experiment. The experiments produce many models. You need to choose which model you want to deploy the model. VertexAI is a versatile platform for all these operations. What's included in VertexAI? Essentially, there has been additional lot of products, but essentially from data to feature engineering to training to model serving and monitoring and management, the optimization of the model, it has across many products for this. There is AutoML, which is a managed objective, managed model, managed database, data sets. And there is the custom model, developers like you, where you could use Python or you could use your own container in order to run your machine learning jobs. Essentially, VertexAI is a unified MLOps platform. It's serverless, so it has an operational model. You don't need an infrastructure management. You don't need to start machines. don't need to provision machines. You pay only for usage. For example, a build step runs for 10 minutes. You pay only for the resources of the machine that started automatically managed for 20 minutes. The programming model is different. It's serverless. So it has the underlying model as a service objective. It's not a function. It's not a website. It's model as a service concept. And it has open SDKs. It integrates with machine learning frameworks. Now, using pipelines through your ML workflows, let's see how it helps you to actually build out all the elements of it. So essentially, we have pipelines highlighted on the previous chart. With pipelines, you can automate building datasets, running feature store accesses, training, storing the model, creating an endpoint, running a prediction service. Also, the model monitoring and metadata services could be connected. If I want to name a favorite service from the Vertex AI pipelines, I would name that feature store is one of my favorites, where you are able to access data put together by a database engineer. And as a machine learning engineer, you don't need to build out data sources. You may have a new team member building out the feature store, like a feature catalog for you, or a customer dimension catalog for you. And another feature I like is metadata service, like storing variables, storing the model's metrics, artifacts that you are going to access through the platform. And if you store the metadata, it means you are able to use experiments, optimization, visual optimization, AI accelerators, and explainable AI on the data stored in metadata in order to build out comparisons between different runs, different models, and to actually optimize all the elements of it. Also, you have notebooks, the Jupyter notebooks, where it helps you to build out your case. I would say this is the manual process, but you can build out with pipelines a lot of the steps of it. Why are machine learning pipelines useful? Essentially, it lets you orchestrate the machine learning workflow steps, because machine learning workflow has steps, as a process. You no longer handle all the data gathering, model training, tuning, evaluation, deployment as a monolith. So each step in a pipeline can be controlled, can be seen as a component, and you can use that. You can adopt machine learning ops for production model. If you are a project manager or a team leader, you need a standard way to deploy models for your architecture. By adopting Vertex AI pipelines is a good way to do so. You then have a repeatable, verifiable, and automatic process for making any change to a production model, because it's defined in a pipeline. You no longer have a manual process as well. You can develop steps independently as well. So as you scale out, it enables you to share your machine learning workflow with others on your team, for example, but on the market as well. They can run that specific step and contribute code, which means that, for example, you can have a team just for obtaining the data, just for running the training, just for running the evaluation. It could be a different team or a team member, and they can contribute and run only that specific step of theirs. And they understand and commit code only to that sub-process of it. And now, visually, to show you how pipelines are created, let's see what's in here. So essentially, my friend Pierre Exposito, a fellow GDE, published here a Vertex AI tutorial on this GitHub URL. Go and check it out later. Essentially, you can build out this basic tutorial, which means that you have a get data step where you are building out a training data set. This is an artifact. And you are building out an evaluation data set. maybe this is 20% of your data and this is 80% of your data. Then you are running the training job. It could be a manual training job. It could be an auto ML training job. Based on the training job, you are producing a model. The model artifact and the evaluation dataset, then it's analyzed together with an evaluation step. The evaluation step produces different metrics in order to see that this run, how good it was. It may be accuracy, it may be a metrics, it may be 10, 15 elements of it, metrics that actually help you to decide if the model was good or not. In the code segment, you essentially have a decorator that defines a function, a pipeline function. The pipeline function has the operation like get data. This is this step. Then you have the train step. The train step is this one. And evaluation. The evaluation step is this one, essentially connecting the dots. Once the pipeline has been defined, it needs to be compiled. By compiling, it means that the pipeline will be exported to a JSON file. This JSON file is the underlying process, description of the process of a pipeline. So when you want to run the pipeline, you can use create run from job spec and use that JSON file in order to run the operation, the pipeline. Why it's helpful? Because this is the automation as well. You can trigger this run many times, and that's really helpful. So essentially, we have discussed so far building out the data, building out the training phase. But you need to deploy the model. To deploy a model, you could, for example, have an endpoint. And by running an endpoint, you have a REST API, REST endpoint to get your service done. In this example, there are functions from G-Cloud pipeline components I imported as variable pipe. By using the AutoML objectives, image dataset, for example, and training operation, these are functions from the components that you can call it. In the previous example here, there was a custom code, a custom training of you. Here you can call AutoML jobs as well. The underlying element of this is that you have an endpoint here created, the endpoint, and then deploying the model to it. Essentially, it compiles to a JSON file and the pipeline job is happening. This is also available on VertexAI samples. You need to look up this Jupyter notebook file and you will get this example as well to run it. Now, you got to evaluate your model. You deployed your model. Let's see what else you can build out. A pipeline needs a logic. So far, we were running steps. But what if you need to deploy the model only if it was successful, only if it reaches a certain accuracy? Remember, you are running the pipeline many times a day with any code change, with new data, and something might be better or worse example. So essentially in the pipeline, again, the decorator is there, the pipeline function is there, you have the data set, you have the training job, and you have the evaluation task. What's different here is that these two, for example, the training and the dataset functions are using AutoML creation, but evaluation task is a function that I have written. I didn't include it here because on the slide share is hard to include that as well. But essentially this function defines if the model is accurate or it produces a column or it produces, let's say, a flag, a variable flag. And then you can use, with a domain-specific language, a condition block. The condition block verifies a variable, and this variable is from the eval function returning. So this function returns a flag. That flag could enable further steps. what are the further steps? Let's say that the decision was that this model is accurate and it should be deployed to production. So the flag is true. Then in the code, you have an endpoint creation and then you deploy the model operation. You choose to have replica or the machine type as a constant as well. These are optional elements. You can tune it, but also defaults to a specific machine as well. In the diagram, you essentially see an evaluation that has the model as an input, and based on the evaluation, there is a condition block, and if the condition matches, then it means that there is a deploy to an endpoint. So essentially, you condition when the deploy is happening. You are able to do traffic splitting as well. You can, for example, choose to deploy only to 10% of the traffic. That means that your new model will get some traffic. You can check out the logs, check out the metrics that if the model succeeded, and you can later promote from that 10% to 100% fulfilling. This example is part of the Vertex AI samples as well. So you have this Jupyter notebook in order to try out this sampling as well. So in a nutshell, we have developer-friendly components. We use the Google Cloud Pipeline components which support easy access to Vertex AI services. You can run custom components, not only AutoML. I get frequent questions that how do I build my custom components? You are able to do that. You essentially use a decorator, which use in the background a test factory function that can be used by pipelines. Essentially, you may wonder what's happening in the background. Well, in the background, Q4 pipelines are handled and treated automatically by the system, and it's deployed on a Kubernetes cluster. You don't run this cluster, it's by Google, it's by managed infrastructure. One hidden gem of running the pipeline is that you are able to share component specifications. A component is a specific step in the pipeline. You are able to export that, and the YAML format allows the component to be under version control and share with others or be used by other pipelines. So you can build out a specific step and you can reuse that in a different project as well. For example, a classification step. You could have many projects where you have one certain element reused. In an analogy to, let's say in a website, this feature could be password forget. Password forget is included in many projects, and you just actually export from the previous project and you import it in the new project. Also, pipeline can leverage caching. This is an interesting feature for developers because a pipeline has many steps. You have seen it could be have 10 steps. And if you change something, let's say in the last steps only, the previous steps are actually cached. So you don't need to wait to rerun it. You can change and you can run the pipeline easy. So for example, the long running phase of the training phase, it could be skipped if it's cached and you are working on the evaluation function only. Then there is the metadata service and artifacts lineage tracking, the inverse of a pipeline of the models. So essentially, let's see what we have talked about today. We have talked about pipelines and orchestrating all the elements of the Vertex AI platform. We have talked about datasets, about training them as a substep, about deploying a model, about building by training a model. Then the model is being deployed to an endpoint, and then let's suppose there is a prediction service. All the artifacts are stored to the metadata service, so essentially it helps us to build out all the elements of it. Now, let's see how this is on the interface as well. So essentially, the Vertex AI interface in the Google Cloud Platform, you are able to access it from this project selector. Then you get into this interface where you have the dashboard, the datasets, features, labeling tasks, pipelines, training, experiments, models, endpoints, and all these elements of it. If we look at the notebook, you can have here the user managed notebook as well, but there is managed notebooks which help you to actually, you can create here a notebook as well. By having a notebook, for example, the examples on the GitHub, which I linked in the slides, and you get the slides after the talk, are able to run it on a Colab or in an AI workbench as well. And essentially these workbooks can run the pipeline for you, as in this picture, to see the basics of a pipeline. Now, if I need to show something for you, like in a datasets menu, you are able to create some objectives like image, tabular, text, video of it. And in the image classification, you could have image classification for single label, for multi-label. You can have object detection, segmentation. In the tabular section, you have regression, classification, and forecasting. In the text, you have text classification, text entity extraction, and sentiment analysis. These are objectives that are automatically offered. These are called AutoML objectives, AutoML managed systems. But you can programmatically create your own as well. By, for example, this flowers database was created programmatically by one of the examples I previously mentioned. Essentially, we uploaded the 3000 dataset element of image. Some are already labeled, but for example, if I want to change that this is not a tulip one, I can access it and I can change the classification of it. And here your personnel has access to annotating and running your datasets. Based on the datasets, you are able to train the models as well automatically. Here on the model details, you can choose to use AutoML, AutoML Edge, or custom training as well. And there are some advanced options like how do you want the data split. You want for training 80, for validation 10, for test 10%. Then you actually choose the budget, maximum node hours that you are going to add. You can add here like 2, and then you can start it. Yeah, here it means 8. Essentially, it will run for a 30-minute job, this one. Now, this is one data set of it, but there are others as well. Like you could have an annotated data set effect. Once this is trained, there is the training phase of it. You get here that the flowers have been trained for 28 minutes. After the training phase, you get a model. In the model section, you get this model trained. It has an ID. Think it like a dedicated model, and you have here relevant operations for this model. Once you have the model, you can deploy it. The pipeline actually deploys it, and you get endpoints. Endpoints are API endpoints where you get here in the pipeline, for example, you get an endpoint ID and you are able to directly consume the model prediction if it was a REST service, and it automatically helps you to run all the elements of this. Now, when we talk about pipelines, the pipelines menu holds all the runs of the pipeline, like in a GitOps style. And some of the operations, for example, this line, you could obtain that it ran for 1 hour because it was let's say, the very first execution of this pipeline. It had to be trained, it had to be run. But subsequent executions were only 4 seconds. Why? Because essentially the steps was cached. Here you have the interface of the model visualization. You get a minimap as well. And here you get all the functions, what you have here, all the logs, of that particular steps. It's loading what logs have produced. You have the artifacts of the steps that was created, and you can define based on this some logic. Like for example, the model artifact was here what train score it had. Also, if we look at our endpoint example, I've switched to a new tab on the endpoint example. We have here the endpoint created, the GCP resource. It's here the full endpoint, which is the HTTPS service. There is the value. Essentially, it has a GCP resources parameter, and the model is being deployed, and the model is using that thing. One thing I need to mention is that there is this view lineage, or you have in the metadata service. Let's go to metadata. And in the metadata menu, you essentially have all the elements of it. So if I access a model, I get the lineage, how the model is being used in an artifact way. I need to zoom out in order to get it nice here. So how a model is being created between those artifacts and what the artifacts' role are in the lineage as well. So if we go back to our presentation and we want to see how the pipelines are helpful, we need to understand that these pipelines adapt to changes of data. So when we talk about automatic CICD perspectives, it's very interesting to actually understand that once we have a pipeline, we can react when we change, when we trigger, when we run the pipeline. The simpler one could be Cloud Scheduler. You can have a schedule that the launch is based on a schedule. You can have all 4 changes of any data in tandem with Cloud Workflows or Vertex AI Pipeline. But if you want to detect change in a code base, like a GitHub commit, you need to react on it. You could have a GitHub style where the commit triggers a build step that's done with Cloud Build, and then it builds the pipeline. The pipeline building is a specification JSON file which is stored on Google Cloud Storage. Once the image has been built, because Cloud Build builds containers, builds images, you may store to Cloud Registry and then trigger the AI pipeline for your custom jobs. But the newest one is EventArc. EventArc is a product that reacts to events. So essentially, it detects changes on data on GCP services. For example, you have placed a new file or a new folder on a cloud storage. You are able to automatically detect that, and EventArc will emit an event. You can handle the event using Cloud Workflows, and when you handle the event, you can reuse the pipeline from the Google Cloud Storage service and trigger the pipeline as well. It's interesting that essentially you can build out models frequently. So for example, you can build out every hour by a scheduler, for example, or by any commit. So you commit a change in a code base. Essentially, it starts a cloud build process and it builds a pipeline. Or if you drop a file on the cloud storage, or if an event, a pub/sub event, something happens in the cloud service, you are able to use EventArc to detect the change and to react to events, essentially triggering your pipeline. And the pipeline triggers the build step, and it may produce a better model based on the new findings. Conclusions. Vertex AI is an enhanced developer experience platform. You can build with groundbreaking machine learning tools that power Google. Also, it's approachable for non-developer perspective. It has AutoML managed objectives, which help because it's a no-code solution. You can use the interface, you can upload your CSV files, you can upload your folder of images and run machine learning initiatives. and it gives you managed models as well with the training as well. Also, if you are a developer or a data scientist, it eases your life because it has feature store, it has managed datasets, endpoints, notebooks directly on the cloud without running a machine, a server, without a sysadmin to actually set up all those to you. It's an end-to-end integration for data and AI by building pipelines. So outperform and solve complex machine learning tasks. You have the GitOps style continuous delivery with cloud build. So it helps you to actually automate all the building of models as a website change element. For advanced use case, there is explainable AI and TensorBoard to visualize and track machine learning experiments. So essentially, this concludes all the developer experience and all the features of the Vertex AI platform. If you have any questions, then please ask in the chat in order to see how to respond to your Q&A questions. Essentially, let's see if there is any question coming in for now. Okay, and now, while the questions come in, I have a question for you. So from me, I have a question to you, and you get a gift from the organizers. My question is, what file formats are exported when a pipeline is being exported? In what file format do we export the pipeline? How the system uses this file format? Hopefully you are here and you post the answer on the chat. Thank you for having me here for today. And I welcome you to any Google Cloud conference or any tutorials as well. Yeah, let me write down the question on the chat in order to have for you, in order to respond. Essentially, that's the question in English. You can get it, and somebody will translate you in order to understand also in Spanish as well. Okay, so this concludes my presentation for you today. I want to show you that slideshare.net and Márton Kodok will have the presentation. Go check it out. It has the links to the GitHub, and you can try out the tutorials on the cloud as well. You can ping me under Márton Kodok username also on Twitter or on LinkedIn as well. Thank you for being here. Bye.